All right. This page is going to be on writing equations of parallel and perpendicular lines and slope. Just a review. Our equation of a line, slope-intercept form, is y equals mx plus b. If you remember from Algebra 1, the m stands for our slope and the b stands for our y-intercept, or where it crosses the y-axis. All right. Now, how do we define slope? Who remembers? Slope is going to be the same thing as rise over run. So if we're looking at a graph, it's how much does that line rise and go across. Okay? So it's the rate at which a line is going to rise. Now, there's also an equation that we can use to solve slope problems, if you remember. The formula is y2 minus y1 divided by x2 minus x1. So that's very important to memorize. You can use either of these to find your slope. All right. So when we're writing equations of lines, it's important to remember that parallel lines have the same slope. So we're going to say congruent slopes. Perpendicular does not. Perpendicular are lines that have opposite and flipped slopes. So they're going to have opposite signs and they're going to be reciprocals of each other, which basically means you flip the number over. So I'll give you an example of both of these. Example of parallel slopes, and we'll make sure we label these lines so you are not confused. Slopes would be, for example, 3 over 2 and 3 over 2. These lines have the same slope. An example of perpendicular lines, if I gave you that same slope, 3 over 2, you would first have to change the sign. So since this is positive, your perpendicular slope would be negative. And since this is 3 over 2, we're going to flip it over. We're going to get the reciprocal, and it would be 2 over 3. That would be our new slope. So you flip it over, and if it's positive, it would become negative. We'll do one more example on that. So what if I gave you negative 4 over 7? Could you flip that? So this one is originally negative. So the perpendicular slope would be positive. And I would flip these two over and make this 7 over 4. And that would be our new slope. All right? So when we're writing equations of lines, if I told you to write the equation of a line that is parallel to a specific line, you want to make sure you have the same slope. If you want to make an equation of a line that's perpendicular, you want to make sure you flip the slope and make it negative. An example of your slope, I'll give you an example of our slope problem. If I gave you 3 over negative 2 and 4 over negative 7, 4 and negative 7. These are your 2 points. To find the slope of these, you would simply label x1, y1, x2, y2, and set up your equation. y2 minus y1 divided by x2 minus x1. So I'm going to start with my y2, which is my negative 7. And I'm going to minus my y1, which is my negative 2. On the bottom, I should have my x2, which is my 4, minus my x1, which is 3. Now, something very important to remember. If you have a negative and a negative, that is going to become a positive. They're going to cancel each other out. So negative 7 plus 2 is going to give me negative 5. 4 minus 3 gives me a positive 1. So my answer is negative 5 over 1, or I could just say negative 5. All right, so that's an example of slope. If you would like to write an equation of a line, you're going to put it all together. So an example would be if I said, write an equation of a line parallel to the line y equals negative 4x plus 2 that goes through the points 4, 6. Okay, so putting it all together, what you're going to do is you're going to keep the slope the same because we said parallel. So I'm going to say, okay, I'm going to keep this. I'm going to label this x1, y1, and I'm going to plug it into my formula, and I'm going to find a new b. So my formula would be 6 equals negative 4 times my x, which is 4, plus b. 6 equals negative 16 plus b. Add 16 to both sides. My answer would be that b equals 22. Final answer, use the new b and keep the slope. So my final answer, y equals negative 4x plus 22. So that would be your review of writing equations of lines using parallel slopes. See your notes for more examples.